Today, we'll be going over psi, the probability distribution function. We can go ahead and define psi as being equal to the probability of finding something in an inherent volume. We're going to be looking at psi in relation to an electron in an orbital orbiting around a nucleus. This first graph shows a 1s orbital with a probability distribution function of finding an electron over time. If we were to take snapshots, this is what the probability would look like of finding an electron at some distance from the nucleus is over time. We can go ahead and plot psi squared as a function versus the distance between the electron and the nucleus, denoted as the radius. As you can see here, this function goes on to state that as we come closer and closer and closer to the nucleus, decreasing our radius, that we have a greater and greater probability of finding an electron there. This is true, but only up until an extent. We know for a fact that we will not find an electron at the nucleus, and thus this is not the best model for representing what psi squared really represents. If we go ahead and change our model, as shown, to state that we want to find the probability of an electron inside this shell, drawn in green here, at some distance r from the nucleus, we can go ahead and state that as the total radial probability function. And this gives us a much more accurate representation of finding an electron relative to the nucleus. As you can see, at 0 we have no electron, but as immediately we start decreasing, or we start becoming further away from the nucleus, we get a probability of really finding the electron, and then it dies off again. This is the most accurate representation of a probability distribution, or to state it more clearly, this is the most accurate description of locating or finding the probable location of an electron from a nucleus. Thank you.